Welcome again to my channel, Science Time Discussion. Thank you for subscribing my channel. For the new viewers, kindly subscribe my YouTube channel by clicking the button. Our presentation in this video will discuss the topic, Convection currents examples. Boiling of water. When boiling water on stove or while making tea or while boiling an egg, the temperature of molecules within those liquids increases, and they slowly begin to move in a rapid rate. These molecules get charged up, thus producing kinetic energy. These hot water molecules residing near to the heat source tend to become less dense. They rise above cooler dense molecules. As these hotter molecules rise, they tend to cool down and begin to sink, replacing cooler molecules. These movements occurring within this boiling water, what we call convection currents. Campfires. The hotness which we feel around a campfire is all that convection currents heating up your hand. The heat comes from various kinds of heat transfers such as radiation. But while placing your hand above a campfire, a lot of convection currents rises up towards you. Changes in the weather. The cool air and breeze occurring near to a beach are all the effects of convection currents. The weather changes on a daily basis are all affected by these currents. Convection currents occurring in the ocean. The oceanic currents are also the convection currents. These are caused due to the difference in the water density and the temperature occurring in the different parts of the ocean. Convection currents are present in the air. A good example of convection current is the warm air that rises towards the ceiling in your house. The process happens as the warm air is said to be less dense than that of the colder air. Another good example of convection current is wind. The wind is mainly caused when the reflected radiation of the light from the sun heats up by the air, thus displacing the cooler air. Heating and cooling of your house. Ceiling fans can usually operate in both directions, either blowing air down from above or blowing air up from below. Blowing air down is usually helpful in the summer so you feel the convective breeze cooling your skin. Pulling air up is helpful in the winter because it helps to push the high up hot air down and out toward the walls without blowing directly on you. Some ovens are able to bake by convection. Convection ovens use fans and an exhaust system that circulate the air inside the oven when it bakes, blowing hot air directly across the food. This allows the food to cook faster and more evenly than it would if it were simply placed near the oven's heating elements. It also makes the interior of the oven drier and less humid, which can be better for browning food. Convection current. A convection current is a process that involves the movement of energy from one place to another. It is also called as convection heat transfer. What is the reason that makes you feel hotter when placing hands above a campfire or when sitting next to it? Or why is the movement of liquid so rapid when water is boiled in a pot? These things happen as a result of the convection currents. Convection currents form because a heated fluid expands, becoming less dense. The less dense heated fluid rises away from the heat source. As it rises, it pulls cooler fluid down to replace it. This fluid in turn is heated, rises, and pulls down from cool fluid. This cycle establishes a circular current that stops only when heat is evenly distributed throughout the fluid. As a substance like water is heated, the less dense particles rise while denser particles sink. Once the hot, less dense particles cool down, they sink, and the other less dense particles rise. This continuous process is called convection current. The convection currents tend to move a fluid or gas particles from one place to another. These are created as a result of the differences occurring within the densities and temperature of a specific gas or a fluid. Convection is one among the forms of heat transfers, of which the other two are radiation and conduction. Convection process only happens in the fluids. Examples, in liquids and gases. This happens due to the reason that molecules within liquids or gases are free to move. The heat energy can be transferred by the process of convection by the difference occurring in the temperature between the two parts of the fluid. Due to this temperature difference, the hot fluids tend to rise, whereas cold fluids tend to sink. This creates a current within the fluid called convection current. Convection cannot, by definition, occur in solids because of the inability to create fluid flow in solid matter. The particles cannot move relative to each other but can only vibrate in place. Heat transfer in solids occurs instead by conduction, or the transfer of vibrational energy from one atom or molecule in a solid crystal to its neighbor. There are some exceptions to this in soft solids where the particles can move past each other. Convection is often described as a combination of two physical processes, advection and diffusion. Advection is a transport of matter by bulk motion, as the movement of riverbed silt by the flow of the river. Diffusion is a transport of matter by particle motion from an area of high concentration to an area of low concentration, such as the movement of dye particles spreading through a glass of water. As convection moves hotter matter higher and cooler matter lower, it does so both by moving the matter in bulk, advection, and in a particular way, which is diffusion. For example, convection currents transfer thermal energy through molten rock below Earth's surface, through water in the oceans, and through air in the atmosphere. This is exactly what happens in the Earth's mantle. The hot, less dense rising material spreads out as it reaches the upper mantle, causing upward and sideward forces. These forces lift and split the lithosphere at divergent plate boundaries. The hot magma flows out of the mantle and cools down to form the new ocean crust. The downward movement of the convection current occurs along a convergent boundary where the sinking force pulls the tectonic plate downward. The convection currents rotate very slowly as they move and drag the plates along. Because of convection current, the tectonic plates are able to move slowly along the tectonic boundaries, pushing each other, sliding past each other, and drifting away from each other. The mantle within the Earth's surface flows due to convection currents. These currents are mainly caused by a very hot material present in the deepest part of the mantle, which rises upwards, then cools, sinks again and again, repeating the same process of heating and rising. Mantle convection is the slow, creeping motion of the Earth's rocky mantle caused by convection currents carrying heat from the interior of the Earth to the surface. It is one of the three driving forces that causes tectonic plates to move around the Earth's surface. The Earth's surface is divided into a number of tectonic plates that are continuously being created and consumed at their opposite plate boundaries. Creation occurs as mantle is added to the growing edges of a plate. This hot added material cools down by conduction and convection of heat. At the consumption edges of the plate, the material has thermally contracted to become dense, and it sinks under its own weight in the process of subduction at an ocean trench. This subducted material sinks to some depth in the Earth's interior, where it is prohibited from sinking further. The subducted oceanic crust triggers volcanism. Hence, the convection current is defined as a process of continuous heating up of liquids or gases by the process called as convection. And thanks for now. Hope that you learned from this video. Kindly subscribe my YouTube channel, Science Time Discussion, by clicking the button. Thank you very much. Have a blessed day, everyone.